sketch graphs of the following on separate axes. So we've got y is equal to 1 minus 2x, y is the absolute value of 1 minus 2x, y is equal to minus the absolute value of 1 minus 2x, and y is equal to 3 minus the absolute value of 1 minus 2x. So this is the first one. So we've got y is equal to 1 minus 2x. Probably better to write it as minus 2x plus 1. And then we can use the idea of y is equal to mx plus c, m being the gradient, so everyone along we go 2 down, and c being the y-intercept. So drawing a set of axes, making sure we've labelled x and y. Find the point 0, 1, because this is the y-intercept, which is here. Mark that point, and then for every one along we go 2 down. Same again, every one along we go 2 down, and we can go backwards, 1 across, 1 up, and then we can draw a line through those points and label it y is equal to 1 minus 2x. Now from that we can now do part B. We should also label this point here, because that's going to be quite important to do part B. This point here is obviously a half. If this is 1 and this is 0, this is going to be a half. Right. For part B, we've got to do y is the absolute value of 1 minus 2x. So if we, to do that, if we take this graph and just reflect the bit below the x-axis, i.e. the negative part of the graph in the x-axis, then that will give me that graph. So this is why this point is important, a half. So draw a set of axes, mark on that point, and then this bit here will be exactly the same as this side here. But this point here will go to here, so that's there on this graph. And then we can get, these going up, 1 across 2 up, 1 across 2 up, the opposite thing because we're reflecting it. We get the whole graph of y is equal to absolute value of 1 minus 2x. So, one way to draw a very simple modular function graph is to, or absolute value graph, is to reflect what's below the axis in the below the x-axis, and then reflect it in the x-axis. You should mark on points of interest, i.e. this point and where it cuts the axis. Right, now to do y is equal to minus 1 minus 2x. This is my answer to part B. And I'll draw another set of axes. Now what we've got to remember, if we want to do y as minus f of x, then what we've got to do, if that is f of x, then what we've got to do, minus it, means reflect it in the x-axis. So again, mark on that point, but this point 1 will go down to minus 1. Okay, and then the pattern will continue down that way for everyone along 2 down, everyone back 2 down. And then for this similar sort of idea here, this point here will reflect to this point here. So this point here will reflect to this point here. Okay, and then for everyone along we go 2 down, everyone along we go 2 down. And then this is the graph of y is equal to minus the absolute value of 1 minus 2x. Now for part D, we've got y is 3 minus the absolute value of 1 minus 2x. You've better to think of it as y is equal to minus absolute value of 1 minus 2x, which we've just drawn up here, and then add 3. So basically what we have to do is translate this graph 3 units upwards. So translation 0, 3, that's what the plus 3 means. So we draw the graph. So put this point on first. This point moves up 3 units, so it goes up here, write down its coordinates, which is a half 3. Minus 1 will go to 2, because it goes up 3 units to 2. And then that pattern will be a 2 along, 1 back, 2 down, carries on. And the similar idea is that this point here will go here. This point here will go up to 2, so mark that point at 2, and then the pattern continues everyone along 2 down. And then we get a graph of y is equal to 3 minus the absolute value of 1 minus 2x. So each part of this question was related to the other, and it involves a little bit of using transformation of graphs of function. I hope you've understood, and I thank you very much for watching.